Hi, so this is the first question in the Math Counts Week 5 handout, and it asks for the value of that entire sum. And, some of your first instincts might be, like, let's just add all this up. But we can actually think about it a little bit more systematically and find a more efficient way to solve this problem, right? One that's less prone to error as adding them up would be. So first, let's just look for a pattern, or try to, right? Maybe this is an arithmetic sequence. Maybe it increases by the same amount every time. That would make it really easy, right? So what do we have here? We increased by 13 by 4 to get to 17. Oh, but we increased 17 by 6 to get to 23. So it's not arithmetic. But then from 23 to 27, we go up by 4. From 27 to 33, we go up by 6 again. And this pattern continues for the rest of this sequence. Now, you might be thinking, well, that sucks. It's not an arithmetic sequence. It doesn't increase or decrease by the same amount every time. But one thing we do notice is that, every 2 terms it increases or decreases by the same amount. Since it does repeat, it goes 4, 6, 4, 6. So we know that from 13 to 23, it goes up by 10. Same from 23 to 33, because that's just 4 plus 6, it's going up by 10. And we can say the same thing from 17 to 27. It increases by 10. From 27 to 37, it increases by 10. So what that tells us is we can actually split this entire big sum into 2 separate sums that are each their own arithmetic sequence. So our first one, that can be 13 plus 27, plus 23, which is 10 more than that, plus 33, plus 43, plus 53. And our second sequence, that can be 17 plus 27 plus 37 plus 47 plus 57. And adding up both of these arithmetic sequences will give us the sum of that whole thing, because it's just the same numbers, but it'll make our lives much easier. So how do we find the sum of an arithmetic sequence? Well, it's really simple. There is this formula that says the sum of the arithmetic sequence is equal to the first term of the sequence you're adding up plus the last term times the number of terms divided by 2. But let's real quick try to figure out why this works, right? Because, yeah, there's a formula, but, that's no fun. We need to understand why this works. So let's just look at this first sequence. Well, the sum of the first term and the last term, that's one part of it, right? The sum of the first term and the last term, 13 plus 53, that's equal to 66. But now if you notice, the sum of the second to first term and second to last term, 23 plus 43, well, that's also 66. And then, so the sum of our sequence is just going to be 66 for the first and last, 66 plus 66 for the second to first and last term again, plus 33, which is half of 66. So if it's 2.5 66, well, that's the same thing as 5 halves times 66, which is really interesting because if you compare that to the sum formula, that's exactly what it is. It's the first term plus the last term, which is 66, times the number of terms, which is 5 over 2. Doing this will just give us our sum, which is what we just did here. So that's really all the formula is saying. Now, if we want to actually do this, the sum is, 5 halves of 66. So 66 over 2 is 33, times 5 is 115. Now, let's try the second sum. We can just plug this into the formula. We get first term plus last term. So that's 17 plus 57 times the number of terms, which is also 5, over 2. 17 plus 57 is 74, over 2 is 37, times 5 is 135. So now we just have to add up both of these sums of these individual sequences. So 115, the total sum is going to be 115 plus 135, which is equal to 150. So that right there is our final answer.